The sampling distribution of p hat comes up in Chapter 18 because we're going to learn how to compute probabilities associated with it. Remember that a sampling distribution is the distribution of values that a statistic can take in repeated samples from the same population. So imagine that we're polling on maybe whether you're left-handed or not in a class. And if I only ask 10 people whether they're left-handed, I might get 1 out of 10. But if I get another sample of 10 people, a different random sample of 10 people, it might come up to be 2 out of 10 that second time. So we already know that there's sampling variability, and those p hats are going to vary from sample to sample. The distribution, the sampling distribution, just tells us which values that statistic can take as it varies from sample to sample and how often it takes them. Notice the histogram on the bottom right of the screen. That's one way that we can picture a distribution, and then we can smooth it with a curve. Let's suppose that we take a simple random sample of 1,523 adults and ask each of them if they bought a lottery ticket in the last 12 months. The sample proportion who say yes would be p hat, which would be the number of yeses in our sample, divided by our sample size, which is 1,523. So we know that if we asked a different simple random sample of 1,523 adults, the first p hat would be different than the second p hat. Let's suppose that the true proportion p equals 0.6. If we were to take 1,000 simple random samples and calculate 1,000 p hats, the distribution would look like the picture to the right. Does this curve look familiar to you? It's unimodal and symmetric. It's a bell-shaped curve. So for the meantime, we're going to assume that the sampling distribution of p hat is going to turn out to look like a normal distribution. As such, we can compute probabilities associated with that normal distribution. For example, let's suppose that an opinion poll asks a simple random sample of 501 teens, generally speaking, do you approve or disapprove of legal gambling or betting? Suppose, in fact, that 50% of all teens would approve if asked. So p, the true proportion, is 0.5. Suppose the sample proportion p hat who approve is normally distributed with a mean of 0.5 and a standard deviation of 0.022. So this is our mu, and this is our sigma. What's the probability that a poll will indicate less than 47.8% of teens approve? Well, we can answer questions about variables that are normally distributed by labeling the normal distribution and then finding the appropriate area. So first, let's label our normal distribution with the mean and the standard deviations. The mean here is 0.5. Each standard deviation is 0.022. So to be one standard deviation above average, we would take 0.5 plus 0.022 to get 0.522. And if we add another 0.022, we get 0.544, and another 0.022 would give us 0.566. What does it mean to be one standard deviation below the mean? That would be 0.5 minus 0.022, which gives us 0.478. Another 0.022 less than that for our second standard deviation below average is 0.456. And another 0.022 below that is 0.434. So now we can label our areas. We know from Chapter 13 that 34% goes here and 34% here. 13.5 go in these two spots. 2.35 goes here and here. And 0.15 goes here and here. We want to find the probability that a poll will indicate less than 47.8% of teens approve. Where's 47.8%? It's right here. 0.478 is the same thing as 47.8%. If we want to know what's the probability that a poll will indicate less than that, then we want to shade the area to the left of 0.478 on our normal distribution. So we want this area, and this area. We want everything to the left of 0.478. So we're going to add 0.15 to 2.35 to 13.5. And that comes out to be 16%. So 16% of samples will indicate less than 47.8% of teens approve. Or we'll have p hat less than 0.478. Or we could change it to a probability, which would be 0.16. For now, we'll always tell you that this has a normal distribution, and we'll give you the mean, and we'll give you the standard deviation. In chapters 21 and 22, we're going to have you tell us that it has a normal distribution, and we're going to have you tell us what the mean is and what the standard deviation is. But not quite yet. So for now, just understand that p hat, if it has a normal distribution and we give you the mean and standard deviation, you can compute probabilities of seeing certain p hats since you know the normal distribution.